All right, guys. So questions on the homework.
Someone took my paper and graded it for me. That's probably not true, unless it is.
Problem number you want to look up? 13.
Indubitably, I want to look at the same one.
So 1.3, problem number 13. F of x equals the absolute value of 6x minus 2. And it's going to be a reflection across the y-axis. A reflection across the y-axis. So with any of these here, we need to look at the general form, because we had a general form for reflection across the y-axis. And the general form for reflection across the y-axis was f of negative x. Because when we reflect something across the y-axis, we use f of negative x. So for whatever our new function is, whatever we want to call it, it's going to show us this reflection across the y-axis. We apply this f of negative x. And with this here, we're just going to plug negative x into this function, because f of x, this is our function. And our general form for reflection across the y-axis was f of negative x, which means that we're going to replace every x in this function with negative x. Now we multiply these here, giving us the absolute value of negative 6x minus 2. Questions on this here? Okay. This here would be questions on what we did here. We good with this one here. And that there is the final answer. This is not the same as these are not the same answer. Questions on number 13? We feel good about number 13? Yes? Okay. Is there another one y'all want to look at from the homework? No? I'm going to look at number 3. So number 3, we want to take this function f of x equals x minus 5 and translate it 4 units to the left. So our left and right translation is f of x minus h, where h is the amount that we move the function to the left or to the right. Now for us here, now that value of h is 4, but would it be positive 4 or negative 4? Because since it is moving to the left, it would be negative 4, because left is negative, right is positive. Now we don't leave it as this negative negative, we write it as plus. Questions on how we got to this point so far? Because again, we're just using the general form for our horizontal translation, that f of x minus h. And we plug in our value of h here is negative 4, because we're going left 4. And just like the last one, we're going to place x with its new part. So here we would have x plus 4 minus 5. Because we don't have f of x anymore, we have f of x plus 4, which means every x in the equation needs to be switched to x plus 4. Now we don't need the parentheses anymore. So we can drop those parentheses telling us that we have x plus 4 minus 5, yes? 4 minus 5 is what? So our new function should be x minus 1. That's number 3. If you want to change any of these answers, you guys can change them. Okay? Questions on this so far? All right. We can answer more questions tomorrow, but we're going to go on and look at the notes today. Writing an equation of line. So what we're doing today is writing equation of line. So we'll be given information about the line, and we want to write the equation of a line and answer a few questions about it. There's two main equations of lines that we are going to use or talk about. One of them is slope-intercept form, y equals mx plus b. Y'all have done a lot of this Algebra 1 geometry before they're writing the equation of a line. Now we call it slope-intercept form because the line has two main parts. The slope, m, and the y-intercept, b. Slope-intercept. Now the other equation of line that we'll use is point-intercept form, slope point form. Now we call it slope point form because it still has the slope, and the x1, y1 is a point. So the main two parts of this equation is a slope and a point. Now just as a reminder, our equation for slope is y2 minus y1 over x2 minus x1. And we can use this equation to find the slope. Now, you've used both of these equations before. You've used point slope, you've used slope to intercept. You found equations of the line from these two here. Now, there is such thing as two-point form. I wouldn't use two-point form. I wouldn't even write this down. Because the equation for two-point form is just slope point form, point slope form, but instead of writing m for the slope, we actually write out its equation. We plug that equation in. I think it's better to do as they say, we find the slope first and then use point slope form. That's going to be easier. There's less stuff to keep track of. But this here is two-point form. I think it's easier just to find the slope and then use slope point form. Use one of those points to find the equation of the line. Questions on this here so far? Mm-hmm.
Is that a 1/2 or
y2. So slope is equal to y2 minus y1 over x2 minus x1. Mm-hmm. All right. So the first problem we're looking at is this one here. The graph shows the distance asteroid 2012-8DA14 travels in x seconds. Write an equation of a line and interpret the slope. So the first two things we need to do, we need to write the equation of a line and interpret the slope. Then the asteroid came within 17,200 miles of Earth in February 2013. About how long will it take the asteroid to travel that distance. So 3 main questions we need to answer. Guys, answer yourself. So we need to determine how long it's going to take it to travel 17,200 miles. Is the final thing we need to do. But first, we need to find the slope to be able to find the equation of a line. We also need to find the slope to interpret and to tell us what it's telling us. Now, slope, Rm, is equal to y2 minus y1 over x2 minus x1. Now we do need 2 points to find the slope. Now it gave us one of the points at 524, where 5 is our x value and y is the 24. So we can plug 24 in for y2. But if we do that, we also have to plug its corresponding x value into x2. Whatever y value we put first on top, its corresponding x value has to go first on bottom. Is there another point that they gave us? Well, they gave us this here. Well, the only other nice spot is this point down here at 0, 0. So that there is going to be our other point. Now at this point here, we can solve our slope, find the slope of the line. Now there's 2 ways we can do it. One of them is we can do it by hand. 24 minus 0 is 24. 5 minus 0 is 5. Now the question is can we reduce 24 over 5? Is 24 divisible by 5? So we have 24 fifths. The other way we can do is we can plug it in the calculator. We can say 24 minus 0 over 5 minus 0 is 24 fifths. That is as reduced as it gets. So that tells us our slope is 24 fifths. So we found the slope. This will help us find the equation of the line. But before we do that, we need to interpret the slope. When it says to interpret the slope, what it's asking us to do is explain in words what the slope is telling us. So the slope has 2 main parts. It has the x and the y. The x is time. The y value for this is distance in miles. Now slope, change in y over the change in x. So the change in x is 5. So it's saying for every 5 miles, because the x is the change in x, our x value, our distance. So for every, seconds. That's why I was getting some confused faces. For every 5 seconds, because x is our time. For every 5 seconds, when we go right, we travel how far? It travels 24 miles. So interpreting the slope is saying that for every 5 seconds, it's going to travel 24 miles. That's all the slope is telling us. It's telling us that for every 5 seconds, we're going to go 24 miles. And that's it. Questions on this here? Questions on anything we've done so far? We good with this here, yes? Now there's multiple ways to interpret this slope, because we could say this here. Now, if we converted this to a decimal, 4.8, we could say for every second, it travels 4.8 miles. We're saying the same thing, but we worded it differently. Questions on this here? Now, you don't have to write both ways. I just need one. And again, when you interpret the slope, I will be reading it, especially on the homework, and seeing, is it telling us what the slope is telling? If it is telling us the same thing. There are different ways to write this. And that did answer part of the question. We did complete the interpret the slope. Next thing we need to do is find the equation of the line. Now there's two starting equations we can use. Y equals mx plus b, or y minus y1 is equal to m times x minus x1, our slope-intercept form and our point-slope form. Either equation that we use, we'll have to get it to y equals mx plus b form. But the main thing is what are we starting with? Well, we have a point, and we do have the slope. Now, we would start with y equals mx plus b, our point, or our slope-intercept form. If we do have the slope, we do. Do we know what the y-intercept is? Because the y-intercept is the value, or the spot where it crosses the y-axis, yes? And the x value is what? 0. So we could say y-intercept is really the point 0, comma b, yes? So do we have that point? Do we have that y-intercept? Oh, yes. And that y-intercept is 0, 0. So we could use slope-intercept form because we do have the y-intercept. So b would be 0. And the slope would be 24 over 5. So our equation of a line here would be y equals 24/5 x plus 0. But we can simplify this to y equals 24 over 5 x, because the plus 0 does not add anything to this equation. Questions on how we found the equation of a line? Questions on any of this so far? So did we answer everything? We interpreted the slope, yes? Found the equation of a line. But it did ask one other thing about how long does it take the asteroid to travel that distance, that 17,200 miles. So we need to figure out that last part of the question. Now, 17,200 miles is a distance, yes? Would that distance go in place of x or y? It would go in place of y. So we can take the equation, replace the y with 17,200 miles. Now we just need to solve this equation for x, yes? So how can we solve this for x? Well, what is with our x value? 24 over 5. How are they? What's the operation between those two? Multiplication, yes? The only way to undo multiplication is with division. So we're going to divide both sides by 24 over 5. Because 24/5 divided by 24/5, anything divided by itself is not 0, 1. Anything divided by itself is 1. So the 24/5 x divided by 24/5 is going to be x. Now, luckily, we don't have to do 17,200 divided by 24/5 by hand. We can let the calculator do it. And that gives us approximately 3,583. So how long does it take it to travel 17,200 miles? 3,583 seconds. Now, it didn't ask for this, but if we did approximate this, hold on a little bit, it would be a little shy, but it'd be about 1 hour. It'd be about 1 hour. It's actually 17 seconds short of 1 hour, but it is approximately, I would say that's close enough to say 1 hour. Questions on this here? Questions on anything we've done so far? Mm-hmm. Is that good? Mm-hmm. Questions so far?
Quite a bit. I'll watch the video.
Okay. Now, we can understand that this is actually considerably fast, yes? Well, 17,200 miles is quite a distance, but it's also, I would say to the point it's kind of hard to grasp how far 17,200 miles is. We do know how far it is to the border, yes? From here to the Oklahoma border. From here to the Oklahoma border is 7 miles, because we've seen the sign 7 miles from here to the border. So traveling at this distance, this speed, it would take approximately 1.5 seconds to get from here to the border. That is how fast this asteroid is traveling. Yeah, no, I mean, if we could travel that fast, that'd be nice. But this asteroid 2012 DA14 is traveling that fast that it could get from here to the border, that's 7 miles, in 1.5 seconds. Because if I remember right, from here to Siloam, if we actually drove the road, is about, what, 20 miles? It'd take about a little over 4 seconds to get from here to Siloam. That'd be nice. But I say that and do those calculations so we get an idea of kind of how fast this is. We know that being able to travel 17,200 miles in an hour is quick, but that kind of gives us an idea of how quick that is. So questions on finding the slope, interpreting the slope, finding the equation of a line, or solving this here. We're going to look at another one. We're going to look at this here. The graph shows the remaining balance Y on a car loan after making X monthly payments. Write an equation of a line. So that's the first thing. One of the things we're going to need to do is we're going to have to write an equation of a line. We're also going to have to interpret the slope and the y-intercept. And then it asks us to find what is the remaining balance after 36 payments. So after we make 36 payments, how much is left? So the first thing we can do is to find the slope. We can find the slope of the line. So y2 minus y1 over x2 minus x1. And again, to find the slope, we need 2 points. And they did give us 2 points this time. They gave us 0, 18 and 10, 15. Which y value do we want to use first? 18. Minus the other y value, which is 15. What x corresponds to our 18? 0 or 10? The 0. Because whichever y value we put first, its corresponding x value has to go first. Y and y, x and x. Now, 18 minus 15 is 3. 0 minus 10 is negative 10. I like having the negative. If the slope is negative, I like putting the negative on top or in front. I don't like leaving it on bottom of the fraction. But solving for this here, we find the slope is negative 3/10, 3/10. The slope is negative, so the line, the equation of the line should be going down. Yes? Is the line going down? Yeah. So that does tell us we do have the correct sign, at least for the slope. Now, I'm going to rewrite this again. You don't have to, because the other way we could have done this is 15 minus 18 over 10 minus 0. You don't have to write this. 15 minus 18 is negative 3. 10 minus 0 is, do we get to the same answer? So, questions on how we found the slope before we interpret the slope. So, x, the x-axis, our change in x, the bottom of this fraction is the number of payments, yes? The y-axis is our balance. So here we're saying for every 10 payments, the balance does what? The balance decreases by what? 3. D-E-C-R, nope. Decreases by $3, yes? That doesn't seem quite right, does it? Because it seems like it should be a lot more. Because what does that say next to balance? Thousands of dollars. Okay, that makes a little more sense, yes? You make 10 car payments, I hope, but the amount you spent over those 3 car payments is not $3. If it was, and this table was not in thousands of dollars, it was $18, I don't know who in their right mind would make a 60-month payment plan for $18. I would really hope you'd be able to pay that off. Yeah, I'd hope you'd be able to have the $18 paid off. Does that make sense? So we write it this way so that the scale looks better. So we're saying after 10 months, 10 payments, you've paid off $3,000. For every 10 payments, you're paying $3,000 off. So this here is our interpretation for the slope. Now it also asks us to interpret the y-intercept. Now the y-intercept was what? 0, 18, yes? 0, 18. Well, the 0 is our number of payments, yes? So at 0 payments, the total balance is $18,000. What is that telling us? Because we could say just what we said. After 0 payments, the balance is $18,000. Or we can say what? The beginning of balance, the starting balance is $18,000. The beginning balance, the starting balance, the beginning amount. Any way you want to say that, because again, we're just trying to say what it is. The starting balance of this here is $18,000. And that's all that's saying. Questions on how we interpreted the slope or the y-intercept? We good with those there? Yes? So we interpreted the slope and the y-intercept. Now we need to find the equation of a line, yes? But here, it told us we have the what? We have the slope, and we do indeed have the y-intercept, yes? So if we're doing this here, I would start off with our y equals mx plus b, because if we do have the y-intercept, it's going to be easier to do this here, because we know the slope is negative 3/10. Our y-intercept, the b value is the y value at the y-intercept. And what is the y value at the y-intercept? 18. So all we have to do is plug this in. So y equals, we replace m with negative 3/10, x plus 18. And that's as simplified as it gets. We have the answer. We have our equation of y. So far, we found the slope, and we interpreted the slope and y-intercept. We found the equation of a line. Now the last thing we need to do is what? Is determine the remaining balance after 36 payments, yes? X or y, which one is payments? The x is the number of payments, yes? So what we can do is we can replace x with 36. So y, our balance, is equal to negative 3/10 times 36, our number of payments, plus 18. Questions on this here? Now to solve this here, we need to get the y by itself. Is it by itself? Because y is by itself already, yes? We do have the negative 3/10 times 36 plus 18 on the one side. 2, yes? Is there any variables on that side? So is there anything restricting me from just plugging all that in? So grabbing the calculator, say negative 3/10 times 36 plus 18. Now for this here, we're going to go on and convert it into a decimal, because we're talking about money. And this isn't just $7.2, it's what? Thousands of dollars, yes? So it's telling us the remaining balance is 7.2, but really what we have left to pay is $7,200. Is what we have left to pay on this here. Have we answered every part of this problem? Yeah. We interpreted the slope and the y-intercept. We found the equation of a line, and we found the remaining balance after 36 payments, which would be somewhere about there. Questions on any of this here? Questions on anything we've done so far? Last problem we're going to look at today is this one here. The graph shows the distance Allison hikes in X hours. Write an equation of a line and interpret the slope. Then we need to figure out how long does it take Allison to hike 14 miles traveling at the same rate. Find the slope of the line. Y2 minus Y1 over X2 minus X1. Well, we have one of our points already, yes? Its Y value is 24.5. The corresponding X value is 7. What's our other point? 0, 0. .5 minus 0 is 24.5. 7 minus 0 is 7. Now, unlike the last problem, we can't leave it like this. because of one main reason. We have a decimal and a fraction together. We can't have decimals and fractions together. And the nice thing is most every single calculator will simplify that for us. So we can say that the slope is 3.5. Now we do need to interpret the slope. The y, the numbers on top were distance, the numbers on bottom were time, yes? Do we have a fraction anymore? Do we have this distance over time? No, but we still do, because the number on bottom this is understood to be 1. The denominator, yes? If it's not written, it's always understood to be 1, yes? So for us here, we're saying for every hour, or for every 1 hour, she travels how far? 3.5 miles. Because for every hour, she's traveling 3.5 miles. Questions on this here? So did we interpret the slope? Yes. Now, if we wanted it as a fraction, come on. We could have told it to convert it to a fraction, and that would say for every 2 hours, she travels 7 miles, yes? Well, 3.5 plus 3.5 is indeed 7. It is saying the same thing, just in a different form. So, we found the slope and we interpreted it. Now we need to find the equation of the line. Well, just like the last so many, they did give us the y-intercept. The y-intercept is our point 0, 0, which means our value of b is 0. Our slope, in this case, is 3.5. So we have y equals 3.5x plus 0. Do we need to add the 0? No, it's not adding anything. So we can just say our equation of the line is 3.5x. Now the last thing we need to do is determine how long it takes her to travel 14 miles. Yes? Anybody have a guess? Almost. We wouldn't replace the y. So we say 14 is equal to 3.5x. Lastly, we would do is divide by 3.5, telling us x is equal to 4. There's 2 reasons I got to that already. 1, I've done this one already. And 2, because we said a minute ago we said that for every hour she travels 3.5 miles, yes? We also showed that for every 2 hours she travels how far? 7. 7 plus 7 is? So our 2 plus 2 has to be 4. (14) divided by 3.5 is 4. But